Hello, I'm Nicholas Crady. I'm a Lambda engineer. And today we're going to go over how to chroot into your boot drive from a Linux recovery image and why you might need to do so. Once we are in a Linux recovery image, we want to verify that our network is working. So we need to go over here to our network, make sure if you are using Wi-Fi that you log into your Wi-Fi and that it is working. If you have a wired connection, you can verify that the wired connection is enabled here. Once we've verified our networking, we need to open a terminal. And in our terminal, we will be installing the arch-chroot script that we have on our Lambda servers. This script will allow you to chroot into your boot drive, and it's a pretty small script, but you will need an internet connection for this, so please make sure that your networking is working. So we're going to wget our script here at files.lambda.com/scripts/arch-chroot. And we're going to add in a secondary command here after we have downloaded it. We're going to go ahead and chmod this, which modifies the permissions of the script. And we're going to arch-chroot. This allows it to be executed as a script. And then we're going to add in a third command here that is going to add it to our bin directory so that we can run it with the phrase arch-chroot. So we're going to move arch-chroot, or copy arch-chroot into our bin directory. Now, we're going to do this as pretty quick. Once you've seen this, you should be all set. You can verify in your file directory that arch-chroot is there and it is executable. Once you've verified that, we should be all set to use the script. We need to then verify what the boot drive is and then get it mounted into our temporary directories. To find the boot directory, we need to list the block devices. We're going to do that with lsblk. This will show us all the block devices on the machine. Typically, we are working with NVMe 0N1. This is the first NVMe drive. Now, we're going to identify which of these two is the boot partition by examining the size of the two partitions. So we have P1 and we have P2. P1 is significantly smaller than P2. This means that P1 is most likely our boot partition. I know in this case that it is, so we'll work with that. We need to mount these to the mount directory. So we're going to sudo mount dev NVMe 0N1 P2, because we're going to mount our root directory first, to the mount directory. Then we're going to mount dev NVMe 0N1 P1 to the mount/boot/EFI directory. Functionally, this will recreate the root partitioning and the boot device. So this allows us to chroot into the mount directory and act as if we are in the OS itself, the boot drive OS. Now, we're going to use the arch-chroot command that we just set up, and we're going to chroot into the mount drive. This will put us into a different directory, and you can see that it says we're a root user. This means that we do have super user privileges here. This is dangerous if you are not careful with the commands that you run, so we do recommend that you take care with what you do while you're within this root user. So we can verify that we are in the root directory of this. We know that this is our boot drive because we've set it up correctly, but you can verify that you are in the root directory of your boot drive if you know the files on your system. So in this case, you can see these are all the files that are on our boot drive. You can verify again by going to your home directory. In your home directory, you should see home directories of the users that are on your boot directory. So in this case, the only user we have on our boot drive is OEM, and we can see that there's the OEM home directory. So if we go to cd OEM and then we print our working directory, we are in home/OEM, and you would see all of the standard files there. From this root shell, we are able to perform many troubleshooting tasks that are essential, like reinstalling Grub, or performing software updates, or even checking and correcting file system issues. So this is a very key part of troubleshooting, and we highly recommend that you're able to do this. If you are having issues doing this, please let us know, and we will work with you to get you through the steps of this process. Once we finish our necessary troubleshooting steps, we'll need to exit this root shell, unmount the drives, and then sync the work that we've done so that it persists through reboot. So we'll need to exit the shell first by simply typing exit. This will take us to our standard Lambda shell from our recovery image. Now we're going to unmount the drives. So we will sudo umount, and then we're going to recursively unmount the mount directory. This will unmount the boot directory as well that we created. Additionally, we want to add in the sudo sync command, and then we can do a sudo reboot at that point. This will boot us back to the boot drive. So we will perform that, and we should be good. You will be prompted to remove the installation media, and you should do so, and then it will boot into your boot OS, and you should be all set to go from there, assuming that the troubleshooting steps worked. For further troubleshooting steps, please refer to our other guides, where we will go more in depth on the individual steps that are necessary in specific cases. Please feel free to open up a support ticket if you need any additional help or need any information clarified. We're always happy to help you out.